morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. And you better have yourself be doing these review problems or I can't think of anything. Something really bad. Yeah, I'll be knocking at your door. Okay, so this is Math SL Exam Jam number 4, I believe it is. Yes, I think it's number 4. I'll put the right title, so it doesn't matter. All right, so number 9. The following we've had this on a test. I know we have. The following diagram shows the graph f of x equals e to the negative x squared. The points A, B, C, D, and E lie on the graph of f. Two of these are points of inflection. Identify the 2 points of inflection. Hopefully, immediately you see that those are points B and D. How do you know? Because at point B, the function goes from concave up to concave down. And then at point D, the function, or the graph of the function, I should say, goes from concave down to concave up. And since they ask you to identify it, and that there are 2 points of inflections, those are the only possibilities that there could be. So BI, find the derivative of f. So f prime of x is equal to, the derivative of e to the blah is equal to e to the blah. In this case, blah is negative x squared, multiplied by the derivative of blah. And the derivative of negative x squared is negative 2x. And if you want to clean it up, you really don't have to, but it would really bug me if I didn't. So I'm cleaning it up to negative 2x e to the negative x squared. So what do we got with II? Show that the second derivative is this. Well, you definitely want to do this. This is looking like product rule to me. I have 2 functions here. I have negative 2x and e to the negative x squared. So remember, product rule is equal to, let's see, I have a u and a v, so it's v du plus u dv. So the second derivative is equal to v e to the negative x squared du times negative 2 plus u negative 2x dv. Well, the derivative of e to the negative x squared, we already did it. It's up here. So that would be e to the negative, or I'll just write it as negative 2x, again, negative 2x e to the negative x squared. Okay, now we got to clean it up till it looks like this. So let's simplify. Negative 2e to the negative x squared. Negative times a negative is a positive, so this is plus 4x, right? 4x, am I messing anything up? 4x squared, loser boy, Becker, e to the negative x squared. Okay. And what have we got here? Well, we need to factor out e to the negative x squared, and I can also factor out, no, I can't, it just says to leave it like this, so, yeah, okay, so I'm going to factor out e to the negative x squared, and that leaves me with negative 2 plus 4x squared, and we're done, really. We have it in that form, but I'm going to go ahead and write it exactly like they asked. You don't really have to, but again, it's just bugging me, so I'm going to. Negative x squared. Okay. C. Find the x-coordinate of each point of inflection. Well, the point of inflection occurs, again, where we go from concave up to concave down, or concave down to concave up, a change in concavity. So that means I set and second derivative tells me about concavity. First derivative tells me where the function is increasing or decreasing after I find the critical points. So I'm going to set the second derivative equal to 0. Note to self, I did not have to be able to do part BII in order to do C because they gave me the second derivative. Excuse me, didn't they? So I'm going to set this doohickey equal to 0. ZPP, yeah, you know me, zero product principal, property, whatever. I set each of these equal to 0. 4x squared minus 2 equals 0, or Now I don't even have to do this because there's no way that e to the negative x squared can be 0. So this is my only possibility. Timeout, hold the phone, Chuck. Hopefully you're saying, why does this say E? This is C. Hopefully you're saying, hey, Mr. B-Dog, this is paper 2. Why don't we just use our calculator to solve this? Well, I submit to you that solving 4x squared minus 2 equal to 0, you can do it a lot quicker by hand than with your calculator. Very quickly we get x squared equals, let's see, 2 over 4 equals 1 over 2. So therefore x equals plus or minus 1 over root 2. Yes? Okay. So we found the x coordinate. So we have 1 over root 2 here and negative 1 over root 2. Negative 1 over root 2. Okay. So use the second derivative to show that one of these points, either one, is a point of inflection. I'm gonna just work with the positive one. Why not? Okay. So how am I going to show that? Well, I can do my handy dandy sign diagram and I can say, all right, this is 1 over root 2. Okay. And do a test point to the left. The test point would be 0. Yes, we know this. Hopefully this is going to be negative because we see that it's concave down. So if I let 0 e to the 0 is 1. 4 times 0 is 0, minus 2 is negative 2. Negative 2 times 1 is negative 2. It is indeed negative. Okay. And then to the right, I know it's not 1. 1 over the square root of 2 is greater than 1. Actually, I could use 1, couldn't I? Let me think about that so I'm not saying something stupid. Yeah, I could use 1. So let's replace with 1. So let's see. 4 times 1 is 4, minus 2 is 2. So this is positive. And 1 over e to the 1 is positive. A positive times a positive is a positive. So life is good. Okay, but that's not good enough. What we need to do is say that the second derivative of 1, let's see, we can say, we can just write it out instead of using mathematical notation. We could say there is a change of sign at x equal to 1 over root 2 from negative to positive. Maybe an easier way to do that, as it just popped into my head, would be f double prime of x changes from, and you can write it exactly like this, negative to positive at, maybe that, I don't know if it's easy or not, at x equals 1 over root 2. All right, so that'll do it. We are done, and we'll see you next time.